Hello, let's talk math dosing. This is stuff for when your doctor says, I need a mg per kg of Serenia on that animal right there, and you go, oh gosh, I hate math. Well, we're going to do some boot camp math right now. So the first thing is, if there is a conversion that needs to start with from pounds to kgs, we got to do that. So let's say I have a 12-pound cat. Okay, 12 divided by the conversion, which is 2.2, gets me 5.5 kgs. And then I've got a 46-pound dog. Great. So if I take 46 divided by 2.2, I'm going to get 20.9 kg. Okay, so now I've got my kgs, and since most drugs are in mg per kg, this is what we needed. So Serenia at 1 mg per kg, that's the dose your doctor just yelled at you, but you also need to go to the bottle and look at what is the concentration. Serenia is 10 mg per mil. Great. So now I have the two things I need and your equation. You're going to write down this equation here. Dose, or mil, is weight, usually in kgs, times the dose, which is mg per kg, divided by concentration, which is mg per mil, and that equals milliliters. Now, some of these things can change. Kgs could also be pounds, that's for sure. Instead of mg per kg, it might be mg per pound, so we have to pay attention to that. Instead of mg per mil, it could be mic per mil, and that means mg per kg could also be mic per kg. All right, it seems complicated, but once you get started, once you keep working on it, it won't be so bad. So let's go for it. I got a 5.5 kg cat. My doctor says I need a mg per kg of Serenia, so you say, I don't even need to math that one. That is 5.5 mgs that I'm going to write into the computer. I gave this cat 5.5 mg of Serenia at this time, at this route. I gave it IV. And you can even divide by 10 without thinking too much. 0.55 mil. There you go. 0.55 mil is what you draw up into the syringe, and then you're giving that IV to your cat. Maybe you're giving it sub-Q. Who knows? Same with your dog. Don't have to do much math. I know that if it's 1 mg per kg, that's the same as 20.9 mg. I divide that by 10. I'm going to get 2.09. Well, I'm not going to write that. 2.09 rounds to 2.1 cc's. Mils and cc's are the same thing, so we can write either. And that's what I'm going to give. I'm going to drop 2.1 cc, and I'm going to give that to the animal. IV, sub-Q, not IM. That's mean with Serenia. Now move on to the next one. Metronidazole. Doc says I need 5 mg per kg of metronidazole in that animal. And you have an injectable metronidazole that you're going to give to that animal in, say, your ICU. So I've got 5.5 kgs times 5, and that equals 27.5 mg. And if you look down there, divided by concentration, divided by 5, and you get your mils. So now that's amusing. 5.5 was my kgs, and it ends up being my actual milliliter dose I'm going to draw up. Sometimes math is fun like that, and if you get used to your doctor's dosing that they like for each one, and you get used to the concentrations of each one, and they just basically math out to being the kgs, that's pretty cool. That's an easy way to remember what you're doing with that drug. Now for the dog, same idea. You take your 20.9, your kgs, got to get my decimal to work, times your dose, which is 5, and that's going to get you a milligram dose, which is 0.5, 0.4, 104.5 mgs. You're going to divide that by your concentration, which is 5, and look at that, 20.9 mil. I'd, of course, round that to 21 mil because that's what I can drop in a syringe. 20.9 is kind of silly, but that's what I would give. Now, cefazolin, everybody gives cefazolin for pre-op injections and every 90 minutes or so in surgery. So take your weight, 5.5, times the dose, or the mg per kg, which is 22, and you're going to get 121 mg for that cat. And that's what you write on your anesthesia sheet. That's what you write in the computer. At this time, 121 mg of cefazolin was given IV as a slow push. But of course, that doesn't work when you're trying to draw up the drug, so you have to divide it by the concentration of the drug, which is 100. So 1.2 is reasonable to pull up in a syringe. And I'm going to do that for my cat. The dog needs some as well, so 20.9, my weight times my dose, which is 22 mg per kg, and I get 459.8 mg. That's what I write in the computer. If I take that number divided by 100, the concentration, I get 4 point, round appropriately, 6 cc's, 4.6 cc's to give IV slow push to that animal. Next drugs, Dex SP and diphenhydramine. We work with these a lot for anybody who's had vaccine reactions in the past or anybody that comes in emergently needing Dex SP and diphenhydramine for a bee sting or a hornet sting or something of that nature. So we take our weight, 5.5, times our dose, 0.2 mg per kg, and you get 1.1 mg. That is what you write in the computer. And then you take it divided by 4 mg per mil, the concentration, and you get 0.28, when we round appropriately, cc's. And I'm going to give that to my cat, usually IM. For the dog, 20.9 kgs times our dose, which is 2. No, I'm sorry, I went down to diphenhydramine too quickly. So 20.9 times 0.2 of Dex SP, that is 4.18 mg that I write in the computer. But what is the dose I'm actually giving to the dog? You divide it by concentration, which is 4, and you get 1, and if you round appropriately, it stays at 1 cc. And that's what you give to your pet. Now, if you see where I'm going with this and you'd like to continue on, just keep pausing and doing all the rest of the bits on your own, and then we can see it later. Otherwise, we'll continue on. Next one is diphenhydramine. That same poor cat got bit by a bee. So we're going to take weight times dose, which is 2, and you're going to get 11 mg. Then you're going to divide that by concentration, which is 50, and you get 0.22 cc's. That is what I can drop in a syringe. That same dog, 20.9 times his dose is still 2. And we get 41.8 mg. And we divide that by concentration. 50 is 0.84 when we round. And that is the dose we can draw in the syringe. Fenbendazole. If you take your weight times the dose of fenbendazole, which is 50 mg per kg, then you get 275 mg. And if you divide that by concentration, you're going to get 2.8 cc's. I know you got 2.75, but we're rounding. And that's how much you drop in each syringe to send home with the pet parent. The dog is going to be 20.9 times dose, which is 50. And that is 1,045 mg. This would be really mean if some doctor did this to you and said, we're going to make this dog take this much, but if you divide it by 100, the concentration, you get 10.5 cc's. That is a lot of fenbendazole to have to eat. But he might have to do it. Now, buprenorphine. Buprenorphine for my 5.5 cat times 0.02 mg per kg. The dose is 0.11 mgs. Again, that's what we write in the computer. I gave 0.11 mg IV at this time. Something like that. And if you take it divided by concentration, you're going to get 0.37 cc's. That's what you've pulled up in your syringe that you've delivered IV. The dog, 20.9 times dose, 0.02, is 0.418. At this point, you might be saying, why aren't you rounding your MIGs? Well, because I don't have to. I can write milligrams in the computer just as they're written, no problem. But when it comes to drawing up something, I need to round appropriately because only certain volumes sit in certain syringes. So if I have 4.138 mils of something to draw up, well, I can't do that in a 6 mil syringe that would hold the first 4 mils that I need. So that 0.168 that I need, I'm not going to go get a tuberculin syringe and then also an insulin syringe to make that happen. No, I'm just going to round my cc's, but my milligrams can stay about what they are. But now we have to figure out how many cc's does this dog get. So I divide by concentration, 0.3, and I will do 1.4 cc's to give to this dog. Bupivacaine. Your doctor asks for 2 mg per kg of bupivacaine for a laceration repair. So 5.5 kgs on that cat times our dose, which is 2, would give me 11 mgs. That's what I write in my computer. And then I divide it by concentration, which is 5. And I can use 2.2 cc's on that cat to numb up his laceration. For the dog, kgs times dose, which is 2, would get me 41.8 milligrams. And I divide that by 5, the concentration, and I get 8.4 cc's of bupivacaine that I can use to numb up his laceration. Now we come to dexdomitor. So, I'm going to give you a second. If you were writing things down, keep writing them down. Otherwise, I need to erase some space so you can see where I'm going to go. All right, I am erasing. And dexdomitor is kind of a weird one because we moved to micrograms. Their dosing is usually in micrograms. So we can either memorize that dexdomitor's concentration on the bottle says 0.5 mg per mil, which translates to 500 mic per mil, and then mic for mic will work. Otherwise, if your doctor says mic, if you divide that by 1,000, you will get mig. So 10 mic divided by 1,000 would get me 0.01 mig. That is the same thing as 10 mic. So you could memorize it that way. I take mic divided by 1,000 to get milligrams, and then I can use milligrams with the milligrams that's on the bottle. So let's do it both ways. Okay? And get rid of some of this extra that I put in there. So the cat is 5.5 times, we'll go with just micrograms first. It says 10, I'm going with 10. So the cat's 55 mig, mig or micrograms. And then micrograms has to work with micrograms. So 55 divided by the concentration, which is 500, gives me 0.11 cc's of dexdomitor to make the cat sedate. Now, if we do it the other way, we're going to remember that Mike actually converted to 0.01 mig per kg. Okay, we can do that. So I'm going to take 5.5 times 0.01, and I'm going to get 0.055 milligram mg. Remember, whatever we convert to, we have to stick with the entire time. So if I'm going to stick with milligrams, then I'm using what the bottle says, which is milligrams. So I take my 0.055 milligrams divided by the concentration, which is 0.5 mig per mil, and I get 0.11 cc's. So you see, the cc amount doesn't change, and that's how it's supposed to be. The cc amount was never supposed to change. So you just have to make sure that if you have mics and you're trying to figure out how do I convert mic or how do I convert the milligram concentration on the bottle to mic, you just have to stick with whatever you pick. You don't mix and match with these things. You have to stick with one and pick it. Now we move on to the dog. We have a 20.9 kilogram dog times the dose, which again, we'll start with the mic. 10 mic. And that equals 209 mic. Again, I started with mic, I'm sticking with mic, therefore I'm dividing by the concentration of mic. So 500 mic or micrograms per mil, and that equals 0.42 mils to make the dog sedate. Now, if I'm going to do it the other way, I'm going to convert to migs first and stick with migs, which is already on the bottle. 20.9 times dose, which for this one is 0.01 mig per kg, is 0.209 mig. Because again, I started with mig, I have to continue with mig, and now I have to divide by mig, milligram. So 0.209 divided by 0.5 mig per mil will get me 0.42 cc's. Again, the cc's or the mils will not change. That's the point. But whatever you're going to use as your mic or milligram dosing, you must stick with it all the way through the problem. We cannot stop, we cannot mix and match mic and migs, or you will get a very strange answer.